Last couple times we solved systems of linear equations by substitution. The way we did that was because there was a variable like all by itself on one side of the equal sign. That was nice to do that. Can you see here on number 1, I got two different like equations, a red one and a blue one, excuse me, red one and a green one, but there's not a variable all by itself on one side of the equal sign. Agree? It wouldn't be hard to get a variable all by itself on one side. You could totally do it, but there's a better way to do this. I got a question for you. Are x's lined up on top of each other? What do you think? Are the x's like stacked on top of each other? Yes or no? Are the y's stacked up on top of each other? Yes. And here's an important fact that a lot of people don't realize. Are the equal signs stacked up on top of each other? And then the constants after that. See how everything is all lined up on top of itself. What we're going to do then is I'd love to just add these together and make a variable go away. This sucks right now that there's x's and y's in the system right here. I want to make one of those eliminate. So put a line right here, just follow my lead. And if I add these together, let's see what happens. Here is 1x plus one more x. What does that add up to be, baby? 2x. And here's the cool part. Do you see right here, there is a negative y plus a positive y. What do those add up to be? Nothing. Those are gone, right? So those I would like to strike out like this. You see that we have just eliminated the y's from that scenario. Equal sign comes down, and 1 plus 3, how do you feel about calling that a 4? You see that I added those together, and an entire variable disappeared, which is called elimination. We have eliminated a variable in that case. Now you see that blue line is 2x equals 4. Could you solve for x very easily? What would you do? Divide by 2. And what would x equal? 2. There's half our answer. We're still looking for like the ordered pair of where these guys would intersect on a graph and all that stuff. So what we got to do is wherever there is an x, we could substitute that guy back in. And this is a little messier than before because I got to go back into one of my equations that I know. So here's what I'm going to do. I'm going to draw an arrow and I'm going to put it in bing, right there for that guy. I could have chosen the other equation. It doesn't matter. I just got to choose one of those two. And if I put 2 in for x, how do you feel about that? Would turn into 2 plus y equals 3. You see that I have like substituted 2 in for x into that bottom equation. And now I can just subtract 2 from both sides and realize that y equals 1. What would I write for an ordered pair? Where would that be? 2, 1, right? X comma y. Is this guy consistent or inconsistent? Consistent because we got an answer. And then since there's just one answer, like there's not infinite answers, is it dependent or independent? Independent. That is another way to solve systems by elimination because they were all stacked up on top of each other, lining up real nice. Can I do that again on the next one? Are x's on top of x's, y's on top of y's, equal signs on top of equal signs, and constants on top of constants? Is that happening? Who's going to go away if I add those together? The x's, so peace out Girl Scout to those. And let's see what we got. What is a 2y plus 1y turn out to be? 3y equals 12. That is awesome how the x's eliminated themselves. So shouldn't y equal 4? Are we okay with that? And then you got to substitute this guy back in. Honestly, I think the bottom one is easier to deal with than the top one because it doesn't have like a number in front of y. How come I subbed it in for y this time? Because that's the letter that we solved for, like we found that y equals 4. So isn't that x plus 4 equals 11? And then what would x equal, baby? 7. Does it go 4, 7 or 7, 4? 7, 4. Consistent because we got an answer. And independent because there's one answer. But bro, those were way too easy, man. Way too easy. Let's see why the next one is a little more challenging. Question 1, are they all lined up on top of itself? X's on top of x's, y's on top of y's, equals on top of equals, and constants on top of constants. Yes. If I add them together right now, is anything going to go away? Nope. So we got to do some math magic. I'm going to make it easy for you. I'm going to pick on this dude right here. He is a minus 2y. What would you love that dude right above him to be instead of a 1y? What would you need him to be? Wouldn't it be awesome if this like green nugget right here was a 2y instead of a 1y? So what could I multiply this green term times to turn him into a 2y? 2. But we got to keep it balanced, so we'll do that to everybody. So please put parentheses around that whole equation on top, and let's take the entire thing times 2. And what I'm going to do is I'm going to distribute the 2 through, but I'm going to like put my result down here. So isn't 2 times x 2x? Are you with me on that? That didn't come out very nice. Then 2 times y is plus 2y. And then 2 times negative 9 is negative 18. Is everyone cool with where I got those numbers from? Do your brain a huge favor and just nice and lightly strike that guy out now. Not dealing with him. I don't want you to black him out. Like, this is not good. Like, you do want to be able to look underneath there later, but I just want to strike him out so realize I am not dealing with you anymore. If I add these two guys together, will a variable go away now? Here's what helps me grade. Could you please, wherever you're going to add, put this bar right here. If you're going to add them together, it's like, hey, here's where I'm going. Let's add them up. So 5x and 2x is 7x. And here's the whole concept. The y's are gone, right? Don't they add up to be nothing? We have eliminated them. And 32 and a negative 18. Might need to grab a calculator for that. And I got me a 14 back on that. So what does that mean about our good friend x? X should be how much? T. Cool with that? There's half your answer. Substitute that back in to find y. You've got 3 places you could put it. You could put it into this new guy right here if you wanted to. You could put it into this pink one right here. Or you could put it back into the OG, just realizing you're not going to use that 2 that's outside of parentheses. Are you with me on that? I have done this for a long, long time. I'm rolling back into that OG because isn't that x nice and just plain Jane? There's nothing in front of it, right? So I'm going to just draw an arrow and show my teacher where I'm putting my number back in for so I can check if we made a small mistake. So I'm going to put 2 in for x. So that's going to be 2 plus y equals negative 9. And then watch our brain farts. How do I move that 2 over? Subtract it. Negative 9. Take away 2 more is negative 11. Ordered pair. 2, negative 11. Consistent because we got an answer. And independent because there's one answer. Nice. Got a cool question for you, but we're going to handle it on the next one. Let's just talk like this. On number 4, is it lined up for elimination? X is on top of x's, y is on top of y's, equals on top of equals, and numbers on top of numbers. Is it lined up? It might not be the most perfect thing, you know, but doesn't x come first in each one of those? That's not a highlighter. Doesn't x come first, right? Then the next term, there are y's next. Then the next thing is equals, and then the next one is constants. I know they're a little slanty, but you know what I mean by like they're on top of each other. Are we cool with that? So they are lined up. Who do you want to cancel? Do you want to cancel the x's, or do you want to cancel the y's? Because if I add them together right now, this doesn't add up to be nothing. That's 4x, right? I want it to be nothing. This adds up to be 1y. I don't want that. Who do you want to cancel? Because the answer is, it doesn't matter. Who do you want to cancel? Let's cancel the y's. Is that okay? So if this is a 2y, what would you need this guy right here to be? So when you add them up, there will be nothing. You need the bottom one to be, if this is 2y, this one can't be 2y. 2y plus 2y is 4y. I want them to add up to be nothing. What do you need? If the top one's 2y, the bottom one's got to be negative 2y. So what would I need to multiply him by to turn him into a negative 2y? If I can get my eraser right here. So he is already a negative y. What would I need to multiply him by right here to turn him into a negative 2y? 2. All right, he is going to be a positive number that we're multiplying by. So I'll distribute and put him right down below. And then I'll strike him out. Say, I don't want to use you no more. Strike him out. And now add those together and get a variable to cancel out. So peace out to the y's. And you can check yours with mine. I do go a little fast because I've done this for years and years and years. So if I go too fast, slow me down. and then pick an equation. It doesn't matter. It's all going to work out. That's what solving a system is. X is going to be true in all of them. They'll all turn out to be the same thing. So if you chose Mr. Top Guy, you can put -7 in for X. If you chose this middle dude, you can put -7 in for X. You could even use this this bottom guy right here and put -7 in for X. It all is going to work out the same. I'm going to go back into the one that we multiplied by. I'm going to put -7 in for X, copy everything else down. And then you just got to watch those signs. I'm going to add 7 over, but that's what -y equals. And then, of course, you divide and get that bad boy. What do you think so far? How do you feel about the concept? I always say this. You don't have to like doing this. Do you understand what we're trying to do, right? I mean, I'll be the first to admit, I'm not doing this on my Friday nights, you know. It's like I don't like doing this, but I know what I'm supposed to do. Are we okay with that? I'll just do it out loud. Consistent or inconsistent? Consistent, dependent or independent? Cool. So let's keep going because it gets a little weirder. First question, how would I solve this system? You have 3 options now I'm going to get into. You could do graphing. I would not choose that. Reason 1, no grid provided. I don't want to graph it. 2, substitution. I would not choose substitution. You choose substitution when there is a variable all by himself on one side of the equal sign. You see that we do not have a variable all by itself on one side of the equal sign. 3, elimination are x's on top of x's, y's on top of y's, equals on top of equals, and constants on top of constants. Yep, cool. I'm going to choose that. Let's cancel x's. Sound okay? Let's cancel x's. But that's a challenge because back here we had to multiply one line. Check these guys out. This is a 5x. This is a 3x. 5 is not a multiple of 3. Do you know what I mean? So we have to do what I call the double down doubler. We're going to have to multiply both equations by something. What would be the least common multiple between a 5 and a 3? Like if I wrote out all my multiples of 3 and I wrote out all my multiples of 5, what would be the smallest number on both lists? 15. So here's our goal. We got to turn one of them into a 15x, and the other one has to be a -15x. Are you with me on that? So let's do it one at a time. Top one, let's turn him into 15x. What would I need to take the top line times to turn him into 15x? 3? Cool. Then let's real quick go down to the bottom one before we lose our train of thought. And I need to turn the bottom one into a -15x. What would I need to take the bottom one times? -5. You see how one of them's got to turn out to be positive, one of them's got to turn out to be negative. When I do this double down doubler, here's what I personally do. I'll recommend you do the same thing. I'm going to distribute, but I'm going to write my new equation off to the right. So this is going to be in blue here, 15x plus 9y equals -30. Because I'm not just doing one, I got to manipulate both of them. I'm going to just start a new line so I don't have all this junk stacked up on top of itself. So down here, -15x minus 25y equals +30. Rock on? Did I do my distribution correct? Cool. Here's what else better happen. Whatever I was trying to cancel, the x's, they better add up to be nothing. Otherwise, I made a bad distribution. Those do. One is a 15x, the other is a -15x. I need to do 9 plus -25. Same thing as 9 minus 25. That is like -16y's. Are you cool with that? And then over here, woo, what is a -30 and a +30 add up to be? 0. So I have a cool question for you. Talk with a neighbor. Will we get one solution, no solutions, or infinite solutions back? Discuss. Cool. They have their thought. I'm going to increase your thought. When I added them together, are there still letters there? There is still a y in there, right? The x's disappeared, but the y's remained. What is my move to get y by itself? How do I get rid of this times -16? So if I did 0 divided by -16, can you even do that? Well, you can always punch in a calculator because you got a 50% chance of being right and a 50% chance of being wrong. But the first commandment of mathematics is thou shalt not divide by 0. I just divided by -16. Can I do it? Did I get no solutions? Did my calculator give me an error, or did it give me a number? It gave me a number. What is 0 divided by negative 16 turn out to be? 0. It is the old optical illusion that just takes experience. If you wanted to do this, that is impossible. Are you with me? But this is quite possible. You can take 0 divided by negative 16. It is cool. So y is 0. So we will get one solution back because I still have a y value. How do I find x? You got 4 choices of where to sub them into. 1, 2, 3, or 4. It does not matter which one you sub him into. We go back into one of those OG equations if we want, and I will figure that out. I'm going to go into this one personally, and you see how drawing that arrow really helps somebody out that has to look at it and go, where did you substitute this back in at? So I would have a 3x. Oh, that's an awesome number, 0. What's 5 times 0? It's nothing, so he's gone, equals negative 6. And then x equals negative 2. Negative 2. So I'll write my answer as an ordered pair and classify him. But I have experience. I have done that very, very quickly, and I know from experience when I turn you loose to go on your own, it doesn't happen so fast. So I need to give you a chance to practice. But I want to ask a couple questions to lead you in the right direction. Number 6, is it ready to run for elimination? X's on top of each other, Y's on top of each other, equals on top of each other, and constants on top of each other. Ready to run? Cool. We're going to do an experiment. The front 2 rows, I would like you to cancel your X's. Are you with me on that? I want you to eliminate X's. The back 2 rows, I would like you to eliminate your Y's. Are you with me on that? So if I'm in the front 2 rows, this is a 2x and this is a 3x. Hold on, back rows. What would you do? What would you want to turn them into to try to cancel out? What's the least common multiple between 2 and 3? 6. Make one of them turn into a 6x, the other one turn into a minus 6x. Are you with me on that? How about you, back 2 rows? What's the least common multiple between a 3 and a 4? I know one of them's negative. Just hold off on that. We're looking at 3 and 4. What would you turn them into? 12 and negative 12, right? Make one of them turn into a 12y, and the other one turn into a minus 12y. Because it's going to work either way we do it. So sorry for all y'all out there in video land. If you canceled x's, it is the top bit of information right here. If you canceled y's, it is the bottom bit of information. Either which way I did it, I got 4-2 back for the solution. Now, you may have done things differently than me also. Because you could have taken this top one times negative 3 and this bottom one times positive 2, and it would still end up working out right. You could have taken this times negative 4 and this times negative 3, and it would still end up working out right. Like, there's many different ways to do it. The main thing is, can you get a variable to cancel each other out? What do you think? Questions for me? Cool. Let's keep rolling. Is that graphing? Would you choose graphing on 7? Yes or no? Would you choose graphing to do that one? No grid provided. Substitution. Is there a variable all by itself on one side of the equal sign? Nope. Elimination. Are we all lined up on top of itself? Now let's work together the same. Let's choose. Because we could go either way, but let's work together. You want to cancel x's? You want to cancel y's? Let's cancel x. This is a minus 2x. What do I need top boy to be for them to eliminate? I need him to be a positive 2x. Work shown? Yes, you got to show me this 2 outside parentheses. I want to see what you're multiplying it by. I don't need to go off to the side because I don't need to multiply both equations. So that way I don't have to rewrite this dude over here. I'm going to go down low again. So that's going to be a 2x minus a 2y equaling a negative 2. Again, if you did go off to the side, it's cool. You know, you're just going to write both equations back. But when I only do one, I'm going to just distribute and stack them and say, peace out, Girl Scout, to you. So let's add them up. What is negative 2x plus 2x? Well, isn't that going to be nothing because that's what we wanted to have happen. Are you with me on that? But now you see, what do our y's add up to be? What does a 2y and a negative 2y add up to be? Nothing. Gone. Both of them are gone. Got to put a number. Would you believe there has to be a 0 left? Here is where we won't get one solution. Would you believe all the letters have disappeared? Cool? So how do I know if it's no solutions or infinite solutions? Hey, what am I doing with these? Adding them or subtracting them? What am I doing? What did we do with everything? What have we done every single time? We've always what? Added. What is a -2 and another -2? -4. All right? So yes or no, does 0 equal -4? Yes or no? No solutions. All the variables have disappeared. So one solution is out. That was no solutions because the leftover statement was not true. Let's classify him. Consistent or inconsistent? Consistent means you got answers. Inconsistent means there were no answers. Inconsistent. The ACT might ask another question. What kind of lines are those? There was no solutions. When you graph that, they intersected never. What kind of lines are those? Those are parallel lines. Right? So cool. Let's try another one. You want to take a wild guess what it's going to turn out to be? It's probably going to turn out to be infinite solutions. Let's see. Who do you want to cancel, x's or y's? Let's talk about e's. Who would it be easier to cancel? The ones with smaller numbers. Are you with me on that? Who's got smaller numbers, x's or y's? I would roll with the y's. It's not that you have to do the x's. It's not that hard. You'd take in one of them times -4. It's not that hard, but using smaller numbers is usually nicer on our brain. So if this is a 4y, what would you need that guy to turn out to be upstairs? You need him to be a positive 4y. I said that wrong because I said 4y out loud, but he is a -4y right here. Don't we need him to be a positive 4y? I apologize for saying it wrong. So don't I need to take the top boy times a -4? Because a negative times a negative will turn out to be positive. Maybe it would have been easier to cancel the x's because it had positives with him. Either which way, that's going to be okay. And strike him out. When you add those bad boys up, x's add up to be nothing, and the y's add up to be nothing. We did the double down doubler of elimination. All the variables are gone. What do you get on the other side? What is a -4 plus +4? So yes or no, does 0 equal 0? Yes. What does that mean? No solutions or infinite solutions? Infinite solutions. Infinite, with an E at the end, solutions in the form. And this is the nasty part. Don't we need to go? I know this is new, but it seemed like last time we did a great job with it. X, y. Here's what sucks about this. In any of the equations upstairs, I do not know what y equals. So we have to solve one of those for y to do this. Who would you rather solve for y? Top boy, middle boy, or bottom boy? Which one's got the least smallest number in front of y? Top boy would be the guy I'm choosing. That's why I don't like to black that guy out. So let's take him over to the side here, and let's solve him for y. What would this 2x need to do? Wouldn't we have to move him to the other side, right? How do you move that 2x over there? Subtract. What you'd be left with is -y equals -2x minus 1. I don't know if you liked what I just did. I did not rewrite this guy. I just moved the 2x over, right, in one move. I think we can handle that once we get used to it. But y is not by itself. There is a times -1 in front of it. How do you get that all by himself? Yep. So everybody divided by -1 changes all their signs. So this is infinite solutions in the form of x, y. You let x be x, and guess what y equals, baby? What does y equal? 2x plus 1. Man, that is weird. I can see that some of you get that like this, and some of you are still a little confused on that. That is normal. If you are confused on getting this, I will help you, right? Let me help you. Let's classify this guy. Consistent or inconsistent? Consistent because we got answers. Dependent or independent? This guy is dependent because there are infinite answers. It's like if I said, what's the answer? You'd go, well, it depends. I got to make up something for x and then sub them in and find y. It depends. You know, there's an infinite number. Cool. Would you and a neighbor work together on number 21? Holy cow, let's take, I didn't say number 21, right? It's number 9, but I saw that 21 in there. Who would you rather cancel, the x's or the y's? The y's have way smaller numbers, right? So between a 2 and a 7, see if you can find something to eliminate. So I chose to cancel my y's, taking the top 1 times 2, bottom 1 times negative 7. And then when I did all that, I got these. I'm going to add them up. 0 of those, right? Those canceled, and so did those. And just don't get optical illusion. Negative 70, take away another 70 is not 0. It is a negative 140. What do you think? One solution, no solutions, or infinite solutions? These are my favorite, because there's no real work to do after you get it done. There is no solutions, which is inconsistent. And then the other thing that sometimes I need to apologize for is I'm really good at multiplying. So if I go too fast for you, I'm sorry, I need to slow down. So it's totally cool if you use a calculator. It's totally cool. It's just, sorry, when you're like a pro, I go real fast. So adding those up, x's cancel, y's cancel. I'm left with a 0 on the left, which means I either have no solutions or infinite solutions. What do you get when you add those two dogs up over there? 0. So what does that mean? Infinite solutions. In the form, pick one of these guys right here and solve him for y. This would probably be the easiest one to solve for y out of all of those guys. So infinite solutions in the form blank, blank, blank. I got to take this guy down here, and I'll just start from scratch in case people are a little curious what my first move was. You really don't need that green line, but don't you need to move this 9x over to the other side? And then you divide everybody by 3. If you need to show baby steps, you do that, man. This is a lot of stuff all happening at once. So sometimes it's nice to get back to the basics. Infinite solutions in the form x comma y. But you don't write y, you put what y equals, and that didn't show up very nice due to a pen malfunction, so I'll try it again. X comma negative 3x plus 4. Out loud, consistent or inconsistent? Consistent. Dependent or independent? Dependent. Here's some homework questions and some test questions right here. How would you solve this system? First guy right here. Like, we don't actually have to do it. We would just say, how would you do it? Would you choose graphing? Did they provide you a graph on this one? Nope. You will answer substitution if one of these equations, or both, has a variable all by itself on one side of the equal sign. Do you have that happening? Nope. So is it all lined up for elimination? I would choose elimination. That would be the fastest way that you know of up to this point to get that done. There are other ways which are faster. We'll learn that another day. What do you think about this one? Graphing is out on all 3 of these. They didn't give me a grid. You know what I'm saying? So it's not going to be graphing. Which one makes more sense, substitution or elimination? See that dude? He's all by himself on one side of the equal sign. To do elimination, I would have to move that 3x over to the other side to get everything to line up. I don't want to do that. I want to do substitution. That's the box and the parenthesis thing. And then the last one is an interesting one. He's definitely not graphing. He's not substitution because there is not a variable all by himself on one side of the equal sign. It kind of looks like it, but that's not an x. That's a 5x. Are you with me on that? So, and it's not elimination either because not everything's on top of itself. What's not on top of itself? Are the x's on top of each other? Yep. Are the y's? Kinda, but guess who's not where they're supposed to be? The equal signs are in the wrong place, right? So what would be easier? That's out, right? What would be easier for you? Well, if I could divide all of these by 5 and they came out nice, substitution would be nice. Does 7 divide by 5? Real nice. you're going to get a fraction of 7/5. Want to deal with those fractions? Nope. So I would line them up. And you know how you'd line them up? You would like move that 7y over and get it to be this equation. Isn't this thing and this thing the same thing, but I moved the y to where he's supposed to be coming second. X is coming first, y is coming second, equals coming third, and constants coming last. So the easiest way would probably be elimination, even though none of those were a perfect fit. Cool? All right, let's rock some homework.